In this video, I will be discussing percentile rank for ungrouped data and grouped data. Now, before we discuss how to compute for the percentile for each kind of data, let us define first what is a percentile rank. A percentile rank is typically defined as the proportion of scores in a distribution that a specific score is greater than or equal to. For instance, if you receive a score of 95 on your mathematics test, and this score was greater than or equal to the score of 88% of the students taking the test, then your percentile rank would be 88. Now, how do we compute for the percentile rank for ungrouped data? In computing the percentile rank of ungrouped data, the following formula is used. Percentile of x is equal to the number of values below x all over n times 100. To better understand how to use this formula, let us have an example. The Department of Labor and Employment, or DOLE, is in partnership with the Bureau of Local Employment (BLE), revealed in their latest labor market trends release which jobs presently earn the highest salaries in the Philippines year 2019. Now the jobs are listed below, and the estimated monthly salary in each corresponding jobs is also listed in the data. Now, the example or the question, determine the percentile rank of computer engineer's salary among other jobs. Now, we look at our formula, the percentile of x. So, let us determine here in our problem what is the x. So, the x here in our problem is the percentile rank of computer engineer. Computer engineer. Percentile rank. We need to determine the number of values below x, and we also need to determine the value n. Now, we have here computer engineer. I highlight it with yellow here, computer engineer. So, the numerator of the formula is the number of values below x. So, let's count the number of values below x. So, we have the accountants and auditors, production supervisors and foremen, and statistician. So, we have 3. So the number of values below x is 3. We also have n. So what is n here? N is the total number of jobs. So let's count the total number of jobs. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equals to 10. And simply plug in these values into the formula. So percentile of x, which is the job computer engineer, and the number of values below x is 3, and n is equals to 10 times 100. So this is equals to 30%. So this means that the percentile rank of computer engineer salary is 30, or in 30th percentile. So let us have the second example. Find how many percent of the jobs has monthly salaries lower than 60,477 pesos. So we look at our table again. We find 60,477. So I will highlight it with green, so 60,000. So any jobs below actuaries. So we have 1, 2, 3, 4, 5, 6 jobs. So percentile, we have 6 jobs, number of values below x. So we have 6 and n is equals to 10 again. There are a total of 10 jobs in the table. And let's just plug into the formula. Percentile of x. We have 6 over 10 times 100. Let me write for clarity. 6 over 10 over 100. That gives you 60%. So that means that there are 60%. Let me reword. So this means that 60% of the jobs has monthly salary lower than or equal to 60,477 Philippine peso. Now let us discuss how to compute for the percentile rank of group data. In computing the percentile rank of group data, we use the following formula. PPR is equals to the quantity of 100 over n multiplied by the quantity of P minus LV multiplied by FP all over I plus CFP. Where PR is a percentile rank, the answer will be always in percentage. And P is equals to the raw score or value for which one wants to find a percentile rank. LB again is the lower boundary, and N is the total frequency, and the CFP is just similar to what is discussed in a previous video, the CFB. But in this case, it is denoted as CFP, which is the cumulative frequency of all the values below the critical value. FP, again, the frequency, and I is the size of the class interval. Now, to better understand how to use this formula, let us have an example. Example 3. Find how many percent of the scores are greater than the cumulative frequency of 38 in the mathematics test scores of 50 students. Now, let us write all the given. So, what is the 38 here? 38 here is the P, the raw score or value for which one wants to find a percentile rank. So we want to find a percentile rank. So the given is 38. Now we make use of this 38 to find in which row rather in the scores interval should be used. So 38 in the previous video I've taught you this 38. Where does 38 falls? If you refer to the interval in the cumulative frequency, 38 falls in the interval here, 28 to 38. So we used the values in this score interval, 36 to 40. So we have, so what do we have here? We have frequency, the frequency, let me use the bold one. For the frequency is 11. And we also have the CFP. I've told you that we must use the cumulative frequency below the critical cumulative frequency, which is 38. Now we use the value below it, 27. So CFP is 27. We also need LB, or the lowest boundary, or the lower boundary. So how do we compute for the lower boundary again? We will just have to look at the score interval and its lower boundary here, 36 to 40. And we will just subtract 0.5 to 36. 36 minus 0.5, that is 35.5. And we have I What is our class interval size? 46 to 50. We have 5 because 46, 47, 48, 49, 50, we have 5 numbers in the interval. And we will just have to compute the total frequency. 4 plus 8 plus 11 plus 9 plus 12 plus 6. That will give you a total of 50. Now we can compute for the percentile rank. So the formula is PPR equals 100 over n times P minus LB FP or over I plus CFP. Let us just plug in all the values. 100 over n, which is 50, P, which is equals to 38, minus LB, which is equals to 35.5. F, the frequency is equals to 11 times 11, and all over 5, the class interval size, plus CFP, which is equals to 27. Now plug in these values into the calculator. So we have 100 over 50 times, we have 38 minus 35.5 times 11 all over 5 plus 27. So we have 65. Now how will we interpret this answer? So we have this answer. That means 65% of the scores are less than the cumulative frequency of 38. And that also means the remaining 35% receive scores that have cumulative frequency greater than 38. Now let us have the second example. Using the previous table, if one of the students got a score of 42, what is her percentile rank? Now we are now given the score 42. So P is equals to 42. Now we look at our table again. Where does 42 falls? The 42 falls in the score interval 41 to 45. It has a cumulative frequency interval of 39 to 46. So 42 falls in this interval. Well, let's highlight it. Now let us extract the needed data or values. So we have frequency here, we have 8, we also have CFP, which we will use the cumulative frequency below it, which is 38. We also need LB. We look at the score interval 41 to 45. 41 is the lowest, then let us subtract 0.5 to 41. So 41 minus 0.5, that is 40.5. Again, the class interval size is 5 and the total sum of frequency rather is 50. Now we plug in this value into the formula. PPR is equals to 100 over n times P minus LB multiplied by the frequency all over the class interval size plus CFP. Plug in the values. 100 over 50. Our P in this case is 42 minus LB, which is 40.5, times the frequency, which is 8. Divide all of this by the class interval size, which is 5, plus the cumulative frequency, which is 38. Now plug in these values into the calculator to get the answer. So we have 100 over 50 times 42 minus 40.5 times 8 all over 5 plus 38. So we have 80.8 rounded to 81%. Now, how will we interpret this answer? So this means that the percentile rank of a student who got 42 rather, is 81%. Now that is how you get the percentile rank of group data.